This is Scott Sims going over my Project 9 streaming IMU data over Bluetooth. So before we go over the code, I want to just, walk through how I have this all wired up and set up. So I actually have the IMU right here on the main body of the drone, and that is being wired to an Arduino Uno R4 here. And then the Arduino is USB connected to my Raspberry Pi 5 right here. The main thing that I actually want to call out here is if we flip it over sideways, we can see that I have this 2.2 kilo ohm capacitor that I've soldered directly onto the SDA line of the IMU. And this 2.2 then is soldered to another wire here that is then connected into the 3.3 volt line of the Arduino. And this is basically just a pull-up resistor. I've had an issue that my IMU was sending zeros. Well, it would start sending initial data for about 1 second, and then it would send all zeros. And I thought I had a bad board, but I had a second board sent. And after basically the same thing happening, I went digging through every form that I could find and found that more or less it's kind of a common problem with the IMU and the Arduino Uno R4s that you have to put a pull-up resistor on there. So I soldered a pull-up resistor to the SDA line, and like I said, it's being run to the 3.3 volts line on the Arduino, and that got everything working again. So that's why there's probably more connections into my Arduino than most people have. Other than that, it's all the same connections. We have red is going to power, black is going to ground, white is the SDA, the blue is STL, and then, like I said, the green is also on the SDA through a pull-up resistor. So that's how I have everything wired up on the drone. So let's kind of look at the code now. And for the Arduino code, I'm not going to spend too much time on this because it's the exact same code as last project. There's literally no difference to it, so I'm going to kind of go through it real quick. I'm using freeRTOS to manage all the tasks, and I have defined a struct data here to queue up once its data has been read from the IMU sensor and is ready to be transmitted, so it's stored and queued up on this IMU struct. And then here's my task to sample from the IMU. As you can see, it's just creating the IMU struct data packet, populating the packet, and then enqueuing it on a queue here. And then I have my transmit tasks, which is getting what's ever been queued up on the queue, and then sending it across serial in CSV format. And remember, the Arduino is plugged into the Raspberry Pi via USB, so we can do serial communication. From there, it's your typical setup stuff here, where I'm setting up and initializing the IMU. I'm setting its operation mode into 9 degrees of freedom mode. I have some extra system health checks happening here, because again, I thought I had a bad IMU. So this is kind of leftover system health checks that I left in there. And then finally, I'm creating my actual queue and then creating my actual tasks. So I'm starting up the sample task, and then starting up the transmission tasks, and then starting the task scheduler, and that kicks everything off there. So that's the code that's on the Arduino. The more interesting stuff, obviously, is on the Raspberry Pi, since that's what's doing the Bluetooth communication. So let me plug in the drone, and then we can connect via SSH into the Raspberry Pi. So I'm plugging in the drone now. We'll have to give it a couple seconds to boot up before we can SSH into it. I'm going to clean up the cables a little bit while I'm waiting for that. Okay, so we should be able to SSH into it now. Okay. I have our Bluetooth folder here. Cool. And this is our code running on the Raspberry Pi. So I have this use simulation global variable here because this is how I was testing the Bluetooth communication back again when I thought I had a bad IMU, so I wasn't getting real IMU data. So I was actually generating fake data to transmit across Bluetooth to at least get that code working. It's set to false now because I have an actual working IMU. But remember that the Arduino is plugged into the Raspberry Pi via USB, so we can get data over serial. So this is setting up the serial port for that. Here is setting up some configurations for the Bluetooth communication. This is the MAC address for the Bluetooth adapter on the Raspberry Pi here, and then binding a port to it. And then just some other variables that we need to get things going. This part isn't important. Like I said, this is the dummy data where I was generating things to transmit over Bluetooth to make sure I had that code working, but we don't actually need this now. Here is reading off of serial. This happens in a background thread here, where basically we're going to read, we're going to connect and make sure that we can get data off of serial that's coming from the Arduino. And then more or less in an infinite loop here, we're just reading data off of serial, and then we're persisting it in this global latest data. And then yeah, again, this is happening in a background thread. So this is just basically constantly happening over and over. We're reading data the next line from serial and persisting in this latest data line in the background. On the main thread here, is where our Bluetooth server is going to start. Is we're declaring our global latest data variable here. We're creating a server socket here that is defined to be running off of Bluetooth. And then we're binding the Bluetooth globals that we set at the top, so the MAC address and the port that we want to communicate over. And then we basically sit in this infinite loop here that we're waiting for a connection to us, and this is a blocking call. Once somebody's connected, we go down into this infinite while loop here, where we're just making our own copy of the latest data. And remember, the latest data is the global variable that's being written to in the background thread, so we protect it with a lock here to make sure we don't have any race conditions. And then finally, we just send the data across our connection to whoever connected to us. And that just runs infinitely. Or until somebody disconnects. And so because my global variable use simulation set to false, we're going to read from serial here. So that's the actual source thread that's going to get started in our main code here. And we start that thread, and then we start the server and wait for a connection. So let's go ahead and do that. So right now we have connected to serial, and we are getting data. We're just waiting for somebody to connect. So let's go look at the remote client code, so what's running on my desktop. This is also pretty much the same code from last project as far as the plotting is concerned. The only thing different is connecting and get data over Bluetooth instead of a WebSocket server. The most important thing to make sure that we have configured properly is the Bluetooth COM port. And how we can check that is if we actually open up our Bluetooth settings, and let me do that real quick. So if we open up Bluetooth settings and go to COM ports, we want to look for the outgoing of the Raspberry Pi serial port, which is set for COM12. And my Raspberry Pi is already connected to my remote computer via Bluetooth, so that's why I'm able to see this. So it's set for COM12, and that's why we have COM12 set here. And then, yeah, other than that, this is the exact same code as last week. I have some global shared data here to queue up as we're getting data from Bluetooth in this infinite loop. After we've connected to our Bluetooth running on Raspberry Pi, the Bluetooth server, we basically go to this infinite loop here where we're reading data that's being sent across, and because it's being sent across as CSV, we're parsing it as CSV where we expect three things, our X, Y, and our Z, our pitch, yaw, and rotation. And we just update our global variables for data queues here to be plotted. And then down here is the actual plots that we set up. So we have a heading plot, a roll plot, a pitch plot, roll, pitch, yaw. And then we have this update plot function here that will just constantly overwrite the data on the plot with the latest updated data from our global queues that are constantly being written to while reading from Bluetooth. And so that data listener runs in the background on a thread. And so we set it on a thread and we start that thread. And then we start our plots, which are animated, and we update them 50 frames per second with this update plot function that we just went over. And then we get everything going. So if we want to see that in action, we can just make sure I'm in the right spot. Remote client, yeah, we can just run python main.py here. It was main.py, right? Yeah. On main pi. Yep. And yeah, so let me make this a little bit bigger here. Make sure that's as big as can be so you can see it. And so right now we can see that our pitch is about 0, our roll is about 0, and our heading is about 0. So if I lean this backwards, and actually let me try and get both screens on here so we can see. I'm probably going to have to shrink this again then. 1 second. Shrink this, and then we'll bring this back on so we can see. I'm going to set this down in the corner here. Yeah, so we can see that as I add some pitch to this and lean it backwards, we can see that pitch is going up. And then as I lean it down, as I lean it going forwards, we should see pitch going down. Okay, and then as I lean it to the right here, we'll get some roll. Then I lean it to the left, get some roll going the other way. And then as I rotate about the z-axis, we can see our heading changing. Cool. So let's actually take this thing flying now, and I'll make this graph a little bit larger. And let's see how it flies. And we crash. That's always good for it. But yeah, that demonstrates the pitch and roll and the yaw being transmitted from the IMU data. Thank you.